Okay, so welcome to today's lesson. We're easing back in after mocks to CT10. A bit of a recap on binary search. We covered this very briefly in year 10. We're going to go through it in a bit more detail now that you have a little bit more Python knowledge. We want to understand how a binary search works, what it's useful for, what its advantages are compared to a linear search. So we think about the two most commonly used algorithms in computer science. It's probably searching and sorting. Now, Google makes billions of dollars out of those two algorithms. So we want to search data so we can find stuff, but not just find stuff, we want to find stuff quickly. If you think of the sheer number of web pages on the internet, Google has to index all of them. It might take us maybe a second to go to every web page. If there are trillions of web pages out there and you search in dancing monkey on Google and expect to find something, Google can find that in a fraction of a second. How on earth does it do that when it takes us a second to go through every web page and there are trillions of web pages? 1 trillion times 1 second is a lot of seconds. It certainly doesn't take Google that long. So it's found a very, very efficient way of searching. So it does matter how quickly an item can be found. The longer we wait, the more resources it takes, the more time it takes, the more processing power, the more electricity, the more damage to the environment. So we want to reduce the processing cost. Hopefully you already know a linear search algorithm, which just starts at the beginning and keeps going until we found something. Today we're going to do a binary search. It's nice and easy. It's not necessarily the fastest, but it's a lot better than a linear search, but there are some disadvantages. So you're used to a midpoint in maybe maths or English. It just means in the middle of a topic you have an assessment. A midpoint in a binary search just means something in the middle. But if we're talking about the middle, then we have to have an order, and that is the downside of a binary search. A linear search will always work regardless of whatever data you've got. You can have the numbers 2, 3, 7, 9, 41, minus 2, 0 in that order or any order. And a linear search will always work because you start at the beginning and you go through each one in turn. A binary search is likely to be faster, not always, but likely to be faster, but it requires you to do that additional processing beforehand, that pre-processing to sort the data first. So how do we do that? Well, we come across this operator. I'll pause the video and see if you can tell me what this operator is. So there was some confusion between modulo, which means do the division and then keep the remainder, rather than the result. This is not modulo. This is integer division, which is just division, always rounded down. So 10, integer division 2 is 5. It's just the same as 10 divided by 5. But 9, integer division 2 is 4. Because 9 normal division 2 is 4.5, but integer division is easier. You don't round up, you always round down. So what does this mean? Start index is almost always 0 at the beginning. It's where you start looking, but it's not always 0 later on. End index is the last item you're looking at. Remember, index is just position within a list. So we say if we're trying to find a page in a textbook, I've got a catalogue in front of me, and hopefully it's got some page numbers on. First page is page 1. The last page, irritatingly, doesn't have page numbers. I'm going to make it up. Oh, yeah, it does. Page 237. So if I want to work out the middle page, I'll do 1 plus 237, which is 238, integer division 2, because it's an even number, it's the same as normal division 2. Oh my goodness, what's that? That's going to be 119. I've done my maths right. Sorry if I haven't. What does that mean? Well, let's do an easier example. If we're looking at this data and we want to sort this data, find something in this data, remember, a computer can't do what you're doing. If I say find the number 10, instantly, because your brains are amazing, you found the number 10, because you can look at all of them at once. Computer can't do that. It can only look at one value at a time. Linear search would start at the beginning and say, is that 10? No. Is that 10? No. Is that 10? No. Is that 10? Oh, yes, it is. And very importantly, people forget this and lose a mark on a linear search. You must say, you stop looking, because there's no point continuing to look if you've already found what you're searching for. So if this is a binary search, it requires us to have them in order. So 4, 6, 8, 10, 12, 14, they are in order. How do we do it then? Well, we look at the middle one first. Well, this hasn't got a middle one. It's an even number. So which one do we look at first? Well, we always round down. Why do we always round down? Because we use integer division, which always rounds down. What on earth am I talking about? Well, let's see. We start at position 0, index 0. We want to keep looking at all of the data up to 5. So 0 plus 5 is 5. Integer division by 2. So 5 divided by 2 is 2.5. Forget the half and it's just 2. So the first one I'm going to look at is the item at position 2, index 2, 8. Is 8 equal to the number I'm looking for, which is what I've said is 10? No. So, one silly thing. Then I know that that's not what I want. And because they're in order, these are also not what I want. So I'm only interested in these numbers now. I've halved my list. It's divide and conquer. Next, the first index, the start index, is now 3 because I don't care about 0, 1, 2. They're too small for me. The last index is 5. Still 5. It was 5 before. So I do 3 plus 5 to get 8. Integer division by 2. 8 divided by 2 is 4. Don't have to do any rounding down. It's just 4. And I say, is that equal to what I'm looking for? Number 10. No. Oh dear. Well, at least I know that that's not what I'm looking for, and anything above it is not what I'm looking for. So now my start index is 3. My end index is 3. So 3 plus 3 divided by 2 is surprisingly 3. That's the one I look at. Is this value what I'm looking for? Yes, it is. I've just found what I'm looking for. And I found it in 1 compare, 2 compare, 3 compares. It's taken me 3 comparisons, 3 steps to find what I'm looking for. If this was a linear search, would I have found it sooner or later? Yeah, a linear search would have taken 1 comparison. No, that's not 10. 2 comparisons. No, that's not 10. 3 comparisons. No, that's not 10. 4 comparisons. Yes, that is 10. Whereas a binary search has only taken 3. That's not 10. That's not 10. That is 10. It's not always faster, but with large data sets, as in 1,000, a million, a billion items, it is so much faster. So this is what it looks like in Python. Start index is at the beginning. End index is at the end. Why do we need the -1? Yeah, we need it because the index starts at 0. So the last index is not going to be the length. It's going to be the length -1. Then we say, whilst we haven't found what we're looking for, and we haven't only just got 1 left, because that would be rather bizarre, we find the one we want to look for. Start plus end, integer division 2. What's the median point, the middle point? Do a bit of debugging. Say we want to start at the beginning, at the end, and look at the middle. Is the item we're looking at what we want to try and find? If it is, yes, great. Why do we set that to true? So that we can break out of the loop, so that we can stop repeating when found is true. Otherwise, if what we're looking for is less than the middle number, then we don't need to look at all of the others on the right anymore. We can go back and ignore half of the list on the right. We change the end. Otherwise, well, at least we found out that what we're looking for is greater than our midpoint, so we just change the left value, the start value. So basically, we ignore all the values on the left. You do not have to be able to produce this, but you should be able to recognize this algorithm or potentially debug it if there's a logic error or a syntax error in it. So let's have some practice, shall we? CT10, I don't think we need to watch the video. Well, maybe we will. It's only 53 seconds. See if you can fill them out yourself. I'll put it on in the background. If you're watching from home, you'll have to watch it yourself. And then let's go through these ones. The start index is 0. The end index is 12. The midpoint is just going to be 0 plus 12, integer division by 2, which is 6. Try and fill out the rest, and I'll guide you through the other activities in a moment. So let's go through an example where we'll have to do some rounding. For this one, our start position, the beginning of the list, is still the beginning of the list, index 0. But we've realized we don't need to look at anything from index 8 up to index 12. So we're going to stop at index 7. We need to do integer division by 2. So 7 divided by 2 is 3.5. Integer division is dead easy. It's just you ignore the decimal place. You don't round up, you always round down. For activity 3, I would always recommend, if you have this in exam paper, to just write the indices in if they're not there already. So the actual data stored is what's in the table already, and we've got index 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. So you don't get confused by thinking about the 10th number and thinking that's at index 10. It's not. We always start indexing at 0. So first time around, if we're trying to find the value 60, I know you can find it because you're intelligent, but a computer is not nearly as intelligent as you. It can only do one thing at a time. What shall it do? It will follow our algorithm. What's our algorithm? It's a binary search. So we start at the beginning. We want to finish at the end. Midpoint calculation then is going to be 0 plus 9, integer division by 2, which is going to be 9 divided by 2, 4.5, rounded down to 4. So, have we found what we want at index 4? Nope. So probably, if we want to be accurate, let's go false. Boolean value. Which side do we discard? Well, it's not just checking if it's what we want, it's also saying, is this value bigger than, is this value greater than or less than what we're interested in? So because this value is less than what we're interested in, we can discard all of these, which makes the data we still want to search this, and smaller, easier to process. So we discard the one on the left. So therefore, we're now interested in what was the midpoint plus 1. So that's going to be 5 now. The end point hasn't changed, and I'll leave you to work out the rest. So for activity 4, you've got the code here. It says, add comments to explain the code. Be sure to comment where the midpoint calculation is, where the target's checked, and the discarding of the unwanted data. So what have we got here? Well, these are the numbers that we want to search. Remember, always put a blank line above your comment so that we know that the comment refers to the line underneath it. And then these are just saying that we're going to have some variables. Please do get into the habit. I know it's not necessary in Python, but it does get you the marks in Edexcel GCSE Computer Science with Python. If you say that there's going to be an integer variable somewhere in your program, it's helpful to define it up at the top in your global variables. So your target is the value to search for. So we're trying to find 13, which is here. I would put some comments in to say start at the beginning. You could argue that's not really necessary because we've already got that up there, and I would agree, but hey. I would not start at the beginning really. Start with the whole data set because you're starting looking from the beginning to the end. Here is where you calculate the midpoint. So that is going to be a comment to calculate the midpoint. Then this is going to check and to see if you found what you want. And then you have to work out which of these is discarding the values on the left and which of these is discarding the values on the right. And you'll need to comment that you found what you're looking for in here. All right, so when you finish, do make sure that you copy and paste your code or screenshot your code into your Word document. And then at the end of the lesson, and it's not the end of the lesson yet, can you upload it to HT8, Half Term 8, Algorithms and Programming 8 for me, please?